So water is a liquid. Before we delve more into water, let's understand how a liquid differs from our other two main states of matter, solids and gases. So we have our solids, we have our liquids, and our gases. Solids are very tightly compact together, so they have high densities. So density is our mass per unit volume, so there's a lot of stuff packed in per volume. Liquids also have high densities because they're still very compact and close together. Gases, though, are super spread apart. They have very low densities, okay? And you can see down here, I have some pictures of solids, liquids, and gases. Now, a solid has a very definite shape. So here's my Apple pencil. It doesn't matter where I put my Apple pencil. It's always going to have this shape. Here is a glass of water. I can take this glass of water and I can pour it into another glass. Now, the volume will stay the same. I'm not going to change the amount of water that I have, but the shape will change. It will take the shape of whatever other container I pour it into. Our gases have both an indefinite volume and an indefinite shape. No matter where I put them, they're going to expand to fill their containers. And then we come to this column right here, okay, where I say strength of IMF. So IMF stands for intermolecular forces. Okay, so we have these molecules, and these molecules are held together by different forces, okay, especially when we're talking about covalent compounds. All right, and so in a solid, everything's tightly packed together, it's not moving around, so those intermolecular forces are very strong. Or if it's an ionic compound, those are bonding forces, and those are definitely strong. If I have a liquid, though, now, while my stuff is still close together, it's moving and it's flowing. And these intermolecular forces are holding those together, all right? And so we have moderately strong intermolecular forces. For a gas, to go from a liquid to a gas, we have to break those intermolecular forces. So these, like, you can think of intermolecular forces as molecular tethers holding things together. Like if I were to hitch my camping trailer up to my car, I have a tether that holds that trailer to the back of my car. And there's different things that I can attach that trailer with. Some are stronger, some are weaker, and that's what intermolecular forces are. Our gases have very weak intermolecular forces because instead of being close together, they're far apart. So we have to break that molecular tether, that intermolecular force, in order to get gas particles to spread apart from each other, okay? And so our liquids, which water is a liquid, okay, have these intermolecular forces. And one thing that we're going to see as we go through this chapter is there's some really unique things that happen with water, very largely because of the type and the strength of the intermolecular forces that water has, okay? And then when we think about the way things exert a pressure, okay, our solids, if I put this into a container, it's just going to press down on that container. My liquid is going to press on the sides of the container and at the bottom of the container. And then again, gases are going to expand to fill their containers, okay? So just a little bit of an understanding so that you can kind of think about water is a liquid, and so here are some of the important things about how liquids behave versus our solids and our gases.